So the advantages of the Genesis system of atoms over the standard periodic table of elements. Well, first of all, it's a more accurate arrangement of the elements based on the quantum numbers within atoms, based on the 4 quantum numbers, based on the quantity of protons and the quantity of electrons within atoms. And those are very important numbers to understand when you're learning chemistry, as they determine how one atom is going to bond with another. So the advantage is that it's a more accurate arrangement of the elements based on those quantum numbers. Secondly, it has a complete and accurate numbering system that corresponds to useful element data. The standard periodic table has an incomplete numbering system. If you notice, it's numbered 1 through 18, and it always excludes the rare earth elements, and it's actually not an accurate numbering system. It doesn't correspond to useful element data, whereas the Genesis system numbering corresponds to valence electrons in the first and second columns, and then it corresponds to valence electrons in the columns on the far right, these main group elements. And then the numbering corresponds to core electrons in the middle here with these transition metals, and also with the rare earth elements. And then the numbering also corresponds to the stable bonding rules of chemistry. There are essentially 4 stable bonding rules of chemistry: the duet rule, the octet rule, the 18 electron rule, and the 32 electron rule. So 2 electrons, 8 electrons, 18 electrons, and 32 electrons is your stable bonding rules. So chemistry is all about the electrons and the interactions of those electrons. So this is apparent from the Genesis system of atoms, and it is not apparent from the standard periodic table. Right away you can see that the Genesis system of atoms is numbered 1 and 2 here, and that is your 2 electron rule. And then over here it's labeled, it's numbered 3 through 8. 8 is your second stable bonding rule of chemistry. Here in the transition metals, it's numbered 9 through 18. 18 is your third stable bonding rule of chemistry. And here in the rare earth elements, it's labeled 19, or numbered rather, 19 through 32, and 32 is your fourth stable bonding rule of chemistry. And the numbering is exactly where you would expect them to be, because these the 2 electron rule is for hydrogen and helium, the 8 electron rule is for the main group elements here, and the elements underneath the foot, underneath hydrogen and helium here. The 18 electron rule is for these transition metals here, and the 32 electron rule is for the rare earth elements here. So based on the numbering system, we can already kind of see the stable bonding rules of chemistry, and then new students have a direction when they first sit down to use the periodic table of elements system. They kind of know already, just based on the arrangement and the numbering system, what the stable bonding rules of chemistry are, without having to memorize additional information. The more you have to memorize something as opposed to just learning the logic behind it, the harder it is going to be to learn. Another additional data point here that can be easily extracted by glancing at the Genesis system of atoms is another one of those quantum numbers, the electron spin. And if you notice here, I have arrows that are showing these columns being shifted, these columns of elements being shifted up or down, and that is based on that element data point, that quantum number, electron spin. So just based on if these columns are shifted up or down, so all the elements in group 1 here are shifted up, so they have up electron spins. All these elements in column 2 are shifted down, they have down electron spins, and that goes through this whole system like that, and you can determine the electron spin of any atom at a glance. This is used in chemistry often for orbital diagrams, and orbital diagrams help determine what type of bond the atoms are going to have. The third thing that is an advantage for the Genesis system of atoms is that this is another quantum number, the orbital geometry. So if you notice here, all elements here are they're color coded here with these green arrows, and then you have this S here, and these are all spherical atoms. Okay, so these all have a spherical shape. S actually doesn't stand for spherical, so you know, people often get that wrong, but S doesn't stand for spherical, it stands for simple. Okay, and then P here, these are all bispherical orbitals, so they're like two spheres like this, and these are P, and the P is for principal, and then all these elements here, the blue that are D, this is diffuse, and then this is fundamental, and these are complex orbitals. These have 4 lobes, and then these have like 6 lobes and are really complex, dense electron orbitals. And again, so that is clear from the arrangement itself. These elements group themselves together based on the quantum numbers, so you can glance at this system and know the orbital geometry just based on where the elements fall in the system. Again, not super apparent from the standard periodic table, especially since they place helium over here with the p orbitals when helium is actually an s orbital. So another reason we need to move helium over here in this first position, so that orbital geometry is apparent based on the arrangement and like elements fall together. So there's at least 4 additional data points for every single element using the Genesis system of atoms over the standard periodic table. And this is not my belief or opinion. This is a fact that can be verified through experiment by simply comparing the standard periodic table of elements with the Genesis periodic table of elements, and then listing and numbering the amount of useful, accurate, and complete element data points that can be extracted based on the arrangement and the numbering system. Okay, so again, this can be verified through experiment. This is not my belief or opinion, and I'll put this up against the most common 2 periodic table of element systems that are used right now, which is the standard periodic table, and then less common is the left step. It's called the Janet left step periodic table, and it can be proven with experiment that the Genesis system of atoms provides more useful, accurate, and complete element information than both of those systems. At least 4 additional data points for every element, and it's just a more accurate reflection of the elements. You'll find based on the quantum numbers, it's just a flat out more accurate reflection of the elements than the standard periodic table and the left step Janet periodic table. So hope you guys keep checking out these videos and keep learning more. Fact check. I don't ask you guys to take anything at face value. Fact check me go to your chemistry textbooks, go to Google. All this information is actually widely accepted. I'm just applying a few more additional data points to the arrangement, and saying that the primary organizing principle should be the fundamental quantum numbers, the universal quantities, not any element behaviors, and especially not any unscientific, outdated traditions. And we're talking about the most powerful, important tool and discovery in the history of chemistry. We need to be as accurate as possible when teaching this information to the next generation. If this information is truly that important, then everybody who graduated high school should have this knowledge and should be able to use this knowledge, but that is just not the case. In fact, our scientific literacy has been on a steady decline in this country for quite a while now. So we need to pick it up, and this is key, guys. This is a huge step in the right direction. If we can get our schools and get the International Union of Pure and Applied Chemistry to adopt this arrangement and system as the standard, as it is just more accurate to the science. And now when science is being used as the driving force, they say, behind policy decision, it is more important than ever that our citizens be scientifically literate. So very important to learn this, guys. Hope you found this interesting and informative. Have a great day. God bless.